everyone, welcome back to Bleed Electrical. Now, in this video series, we'll be discussing on DC circuits. I am Triveli Naidu from the Department of Electrical Engineering at St. Vincent Pallotti College of Engineering and Technology, Nagpur. In the upcoming videos, we'll be looking at basic definitions, Ohm's law, KVL and KCL, then star and delta circuits, then superposition theorem, and ideal and practical voltage and current sources. Now starting with some basic definitions. Let us have a check on conductors. What are these conductors now? Conductors are the materials where electric current can flow freely or easily. So that is what is a conductor. If we take for example all the conducting materials such as copper, aluminium are all conductors. We often see it in our day-to-day lives as in the form of wires. So if you want to understand how does it work out in a conductor, let us see this example. Here you have a conductor with so many electrons present inside it. So these are all the electrons. These electrons, if you pay attention, are randomly allocated. They are not in a particular direction. But if we apply a force to it, it is known as an electromotive force. So if we apply EMF to it, then what will happen? The electrons will now move in one particular direction. So this is the power of EMF. Now here, this is the symbolic representation of a battery source or EMF. This bigger line indicates the positive potential and this smaller one indicates the negative potential. So here, after application of EMF, you find electrons moving in a particular direction. Hence, the rate of flow of electrons is nothing but current. So you find current over here. If you concentrate on this diagram, you would find the direction of electrons with respect to current is opposite. So you'll have to pay this in attention and solve the numericals accordingly. Now, coming to insulators. Insulators are the materials where electric current does not flow freely. Now, insulating materials such as glass, rubber, air, and so many other materials have high resistance. So, they do not let the current flow easily. Like, for example, in this diagram, there is steel. Steel is a conductor. Hence, you find the bulb glowing. Okay, if you replace this material by wood, then obviously what would happen? It would turn out to be an insulator. Okay, now current. Current is the flow of electric charge through a conductor. So an electric current can be compared to the flow of water in a pipe and it is measured in amperes. So amperes is the unit of current. Now this is how the process takes place. The electrons keep moving from one place to another. It keeps jumping. And current with respect to time, the electrons with respect to time is nothing but the current. Now voltage. What is in voltage? An electromotive force or pressure that causes electrons to flow can be compared to water pressure which causes water to flow in a pipe. So voltage will make sure that the electron moves from its position and ensures current. So that is voltage. So as you see in the diagram, this is the pressure being applied gives you this potential. So this is what is voltage. Now power. Power is the rate at which electric energy is transferred by an electric circuit. It is also measured in watts. Now you find here an electric circuit which is having a bulb of 6 volts and a battery of 6 volts and electrons are moving. So you get this float. It glows. Then resistance. The opposition to the passage of current is nothing but resistance. So the resistance makes sure that it will ensure that the current does not flow easily or it will create opposition to the flow of current. So this is what is a resistance. An electric resistance can be compared to the friction experienced by water when flowing through a pipe and it is measured in ohms. Now inductance. Inductance is a property of a conductor by which a change in current flowing through it induces a voltage or an EMF in both the conductor itself. It actually opposes the rate of change of current. So that is what is an inductance. Previously we saw self-inductance, and in the next diagram we could see this is the self-inductance. It is inducing a magnetic field. Okay, there's a field created in this. Okay, it induces a EMF, electromotive force. Okay, and here you have another circuit. If it is kept in combination with this, then EMF is also created in this part of the circuit, that is known as mutually induced EMF. Now, the next part is the circuit where you find this inductance appearing over here. Now, capacitance. Capacitance is something that causes opposition to the change in voltage. The ability of a body to store an electrical charge measured in farads as the ratio of the electric charge to the object, that is Q, measured in coulombs, to the voltage across the object, V measured in volts. So this is the capacitance. You find two parallel plates where the charges get accumulated in a capacitance. So this is a circuit. Circuit is nothing but a closed path in which electrons from a voltage or current source flows, and the circuit can be in series or it can be in parallel or any of the combination of the two. Here you find the series circuit and here you find the parallel circuit. Series is when the items, the circuit elements are connected back to back. And in parallel circuit, these are connected across. Okay, and the advantage being, if in this any of these elements is not working properly, it will not let the current flow in the rest part of the circuit. So hence opening the circuit. But whereas if one of these elements does not work well, still the bulb will glow. So here you find an open, but the circuit is still getting completed via this. So this is the advantage of a parallel circuit. In our day-to-day life, we see the connections are always kept in parallel. This is another example of a circuit. This is here you find a parallel circuit, whereas here you find a series circuit. Ohm's law. The current flowing through a conductor is directly proportional to the potential difference across it, provided that the temperature and other physical conditions remain unchanged. Here you find the Ohm's law. Let us understand this diagram. Now the current wants to enter this part of the element, and there has to be somebody who is applying pressure. So this voltage is somebody which is applying pressure to this current, but resistance will create nuisance to it. It will not let the current flow from one part of the circuit to another. So this is what is Ohm's law. V is directly proportional to I, and the constant of proportionality is known as resistance R. Thanks for watching.